Good morning, everyone.
Good morning, everyone.
Good morning, sir.
Good morning, sir.
Wait a second, guys. My iPad is behaving weird. Hello. You guys can hear me now?
Yes, sir.
Okay. No more echo. Okay, so let's start. So yesterday we saw stage coach problem. Now we'll try to define basic features of dynamic programming based on our understanding of stage coach problem. Any questions before I proceed any further? So if you look at a dynamic programming, so basic features of dynamic programming, if you look at. So first thing is we need to understand what are my stages, right? So first basic thing is how do I divide the problem into different stages? And the stages we connect with the policy decision. So what decision point the decision points are my stages. Now with each stages, there can be multiple states. There can be number of states associated. Suppose if there is only one state possible with each stage, what does that mean? I have only one state possible with each stage. So ideally there will be just one path, right? Suppose n equals to 1, n equals to 2, 3, 4. There is only one state. Do you understand? So there needs to be some number of states in which the process can be in that stage. Then only we have a feature of dynamic programming. Third thing is policy decision. So what you are trying to do? So you can think of policy decision at any stage as transform the current state to a state associated with the beginning of the next stage. So whatever decision you take at this stage, given a state, you will reach to the next state, to a state associated with the beginning of that stage. The reason we say beginning, because I will take another decision there that will take me to the next stage. Fourth one is the solution procedure designed to find an optimal policy for the overall problem. Fifth and very important, suppose in the stage coach problem, suppose in stage 2, so when I'm in this stage, I do not care from which state I have come here. Okay, so we have this Markovian property. The state where I am right now just depends on the where I was, or let me put it in the future. the state where I am right, the state I will be next only depends on the state where I am right now. It does not care how I have reached here. I only care about, like even in this case, suppose if I want to go from this stage to this stage, and let's say we are doing backward recursion, I already know what is the all the future costs. So all I need to know this stage, and that's all. Right. So this is called, as we already have seen, it is Markovian property, based on which the principle of optimality is based. So whenever you are trying to define your stages and states, and if it lacks the Markovian property, you cannot define as or model it as a dynamic programming problem. Keep that in mind. So for a dynamic programming problem, you have to have the memoryless property. The state where you are right now at a particular stage will decide only deciding factor where you will be next. It does not care how you reach to the current state. We have already seen that we solve it backwards. So it starts with optimal policy at the last stage. Because backward recursion makes it very easy for us to proceed forward because we are able to calculate all the future cost of an optimal policy. Apart from that, do we need anything else for dynamic programming? What you have seen so far? After you have defined all these things, most important part is a recursive relation. Recursive relation in the sense that if you have seen the last stage course problem, what we are trying to do, we are recursing backwards. So there is a relation, recursive relation, which depends on, each time it is changing according to your stages and states change. So mathematically, we can present it as a recursive relationship. So suppose n is the number of stages. This is the most important. Once you have identified your stages, states, and what is your decision variable, this is the the relationship on which we proceed with the dynamic programming, or we try to find a solution procedure or optimal decision. Suppose small n is index for stages. So it will be n equals to 1 to n. Sn is current state for stage n. Xn is decision variable for stage n. And Xn star will represent the optimal value of Xn, but given the state. Which state it is in. So I have written it like this yesterday, Sn comma Xn. So contribution of, given that we are moving backwards, contribution of stage n plus 1 to capital N to the objective function if system starts in stage Sn at stage n with immediate decision and optimal decision thereafter. optimal decisions are made thereafter. Okay, now at any stage, read this statement. I'm just written it too fast. Let me try to explain with some suppose. Okay, when we are trying to calculate, suppose we are in stage n equals to 2, n equals to 3, some n equals to 1. Suppose I'm here in this state. Okay, so my state is S1, S2, and so on, let's say. So if I make a, if I'm trying to understand what is the Fn, Sn, Xn. So Fn, Sn, Xn, if I take a this decision, if I take a this decision, and so on. So among all these decisions, there will be one minimum that we represent as Fn star Sn. Okay, so at this stage, in this state, if I making a decision, there could be many options, alternatives. Among these three, which one is the minimum? That is represented by, this is actually nothing but the optimal decision, which we have seen yesterday. Let me just try to show you what it means. So this is your F2S X2. So given in this state B, I have three possible alternatives. Among this is the minimum. So this is my F2 star S and this is my X2 star. That can be represented as Fn star Sn. So for a stage, for a particular state, what should be the minimum or the optimal value given a decision? So in general, recursive relation will always of the form Fn star Sn equals to max of over the Xn, all the decision you have taken, Fn Sn comma Xn. Now this is the most important thing, understanding how to formulate this objective function. It can be of this form or it can be of, if it is a minimization function, minimize Xn, Fn Sn comma Sn. So if I pictorially represented what happens from one state to another state. So suppose this is my state, this is my stage n, this is my stage n plus 1. So what is changing? So suppose I am in stage Sn, I will go to state Sn plus 1. Now, immediate decision that takes me from Sn to Sn plus 1 is Xn. Now value at each state, if you look at it, Sn is Fn, Sn comma Xn. Fair enough. So two things comes here. First thing is contribution of Xn, which is immediate contribution if you take that decision, and all future n plus 1 onwards, what decision you have taken, that gives you your future. So immediate contribution plus all the future contribution, that makes a dynamic programming basis structure, how a state changes from one stage to another stage. Is this clear? Let me write it as contribution of Xn. Immediate contribution plus all future contribution. So as long as you're solving a dynamic programming problem, you have to start with what are my stages in which I can decompose the problem. In each stage, what are my states? Now I have realized my state and stage. I need to decide what is the decision at each point that I take which make the state changes. After that, the recursive relation which will get me the optimal decision or optimal policy to move into a particular state diagram. So any problem of dynamic programming will have this structure. The only thing is your recursive relation changes based on the problems. Like suppose the first problem which we have solved, what is the kind of problem in OR research? What kind of problem was it?
Critical path, Madam.
Hmm?
Critical path.
More importantly, shortest path, right?
Yes.
So, I mean, critical part is more of a project management language. In OR, we say shortest path. Okay, so we have seen one type of example, shortest path. As I said, the study of dynamic programming, we try to understand or do it with, because there is no set, because this recursive relation that will change problem to problem. So we have seen shortest path. Next, we will look at it. It is called distribution of effort problem. Distribution of effort. So let's try to look at distribution of effort problem and how we can formulate it as a dynamic program. So let me first write the data here. So I have medical teams. Thousand of additional person years of life country. One, two, three medical teams. 0, 1, 2, 3, 4, 5. 0, 45, 70, 90, 105, 120, 0, 20, 45, 75, 110, 150, 0, 50, 70, 80, 100, 130. So first note down this data and then I will tell you the pretext on which we are solving this problem. Copied? So what this problem is about, even the organization like WHO or something, they are trying to allocate number of teams, medical teams to different, underdeveloped countries. So these teams will go there and provide, medical care, health education, training programs, etc., so that thousands of additional person years of life can be increased. Now, these streams cannot be broken into zero point 0.5 or zero point 0.2. Whole intact one team will go to one country. So, to maximize the right, to maximize this thousand of additional person years of life, what they need to do is to allocate these teams so that it maximizes the thousands of additional personal years of life, which is my performance measure. There is also an option not to allocate any teams to any of the country. That is also possible. So for example, if I allocate one team to country one, the increase on thousands of additional person years of life for country one will be 45. If I allocate the same team to country two, it will be 20. And if I allocate it to country three, then it will be 50. If I allocate two teams, then it will be 70, 45, and 70 respectively. Or if I allocate all the five teams, this is the number. Now I can allocate all the five to just country one. In that case, what would be the max total thousand of additional years of life performance, increased life expectancy? If I just allocate all the five teams to country one, what happens? What is the value of the life expectancy, additional personal years life?
120.
Just 120. Okay, so that is the trade-off. How do I allocate it so that X maximize the performance measure? Is the question clear?
Yes, sir.
Which allocation maximizes the measure of performance Okay, now we need to solve this problem as a first formulate it as a dynamic programming problem and then solve it as a and then solve it. How do we do that? So first we need to think about what are my stages, what decision I take that changes the states from one stage to another stage. So let's try to understand what are the stages possible in this case. First thing you need to understand, in the last example, we have sequential decision, right? Here, there is no fixed sequence, but it is an interrelated decision. What do I mean by interrelated decision? Are allocating teams interrelated decision or not? What you guys? Okay, let's discuss. The reason I'm asking you to discuss because these are very open kind of problems and we need to understand like linear programming formulation, we need to understand how we proceed. So what are the different things coming into your mind regarding the stages, states and everything? Let's try to discuss. It will help you only when you are trying to formulate it as a linear programming problem. Yes, guys, you can hear me, right?
Yes, sir.
Yes, sir.
So just give it a random thought. What could be my stages here? How do I, partition the problem so that I have stages here?
Stages will be the medical teams, sir.
Stages here could be medical teams. I'm just writing all the options. We'll discuss one by one. So first option is n equals to number of medical teams. Very good. Next. What is the second option you have in? If you guys do not want to discuss, then I will give you. Yes, go ahead.
Stages will be number of countries and states will be like how many medical teams should be assigned to each state.
Okay, so let's just focus on stage for time being. So number of medical teams, number of country, right? Okay, let's try to proceed with number of medical teams. Okay, so Moningi, if I try to define n as number of medical teams, these are my stages. So suppose n equals to, so we'll have 0,
0,
1, 2 till n equals to 5. These are my stages.
Yes.
Now, we relate the decision variable which changes the states from one stage to another stage. You agree?
Yes, sir.
So what exactly is changing from one state to another state? So if we proceed in this manner, number of medical teams. So if I'm at n equals to 0, what are my states?
Every time, can the states be not same, the three countries?
Okay, so let me put it as 1, 2, and 3. Is that correct?
Yes, sir.
1, 2, and 3. 1, 2, and 3, and so on. So whenever we are looking at a dynamic programming problem, we have to ask what is it that changes from one stage to the next? So tell me what exactly changes from one state to the next?
Life of the people's year, person's year, additional.
That will come as an objective function, right? What is that decision we take? So suppose I'm here. Okay, I have to take an decision x n. Agree?
Yes, sir.
What that decision is? That will change me from 1 to 2.
How many medical teams we can assign? That is the stage.
You have defined that as a stage already, right?
Yes. Thanks, sir.
Hmm?
Don't know, sir.
Anyone who would like to join this conversation who also thinks along the same line that I can decide my stages as number of medical teams. So when you are formulating, you need to ask these questions. What is that changes from one stage to another? Okay. So
Yes.
Proceeding in this direction won't help, right? Does that make sense?
Yes. Yes.
Because there is no connection. Suppose if I reach here, now I have to follow the Markovian property also, right? So next stage will depend only on this one. But assuming that if I have assigned whatever medical teams I have assigned, I cannot go back here. So it depends on this stage, right? So this is not going to work. So let's look at another option we have, that number of, sorry, simply n equals to number of, number of country number. So other way to look at the defining stages, first thing is going by what we know already from shortest path problem which we have seen. You realize that these are not sequential decision, but we can think of it as a sequence decision, that first I will make a decision for a country 1, then country 2, and then country 3. Does that make sense?
Yes, sir.
Because I will be doing the optimal decision making. So optimal one, the path it will follow will be like that only. So assuming that I can divide n equals to 1, n equals to 2, n equals to 3. Although they are not sequential decision, but they are interrelated decision. For example, if I assign all the 5 teams to country 3, then I do not have anything to assign to 1 and 2. If I have just allocated 2 teams to country 3, then I have another 2 teams that can be allocated amongst and country 1 or 2. Now, suppose if this is my stages, what is the decision I can take? Action as at each stage. What decision I need to take?
How many medical teams should be, sir?
Very good. Number of teams. Number of teams to allocate to country N, which is also my stage. So when I say x1 equals to 2, what does that mean?
For first country, 2 teams, sir.
X1 equals to 2 means I have allocated 2 teams to country 1, right? Good so far?
Yes, sir.
So my stages, let me write it here, is the countries itself. So n equals to 1, 2, 3. Xn is my decision variable. Now I'm left with my states. Sn. How do I define my states here? Oh, wow. Now, how do I define my states? So let's look at it. When I'm in stage 1, how many teams I have to allocate?
5 teams.
Could you repeat, please?
5 teams.
5, right?
Yes, sir.
Now, let's say I made some allocation and then I move to stage 2, country 2. What had changed? Suppose I had 5 teams. I made a decision xn equals to 1 or sorry, xn equals to 0 or xn equals to 1 or xn equals to 2. What changes in the next stage? I have 5 teams to start with. I'm taking a decision how many teams to allocate based on our recursive relation. What are we left with then? If I allocate 0 teams, how many teams will be there available to allocate to country 2?
5.
If I have allocated 1, 4, 3, 2, 1 and 0. So I can write my state definition as number of medical teams available for allocation. So if that is the case, what would S1 be equals to?
Five.
What would S2 be equals to? State at stage 2.
Sir, it depends on S1.
It depends on S1 or X1.
X1.
What would S3 be equals to?
Depends on X2 plus X.
It will depend on S2 and X3. Sorry, X2.
Yes.
So let's try to draw it. So I have S1 equals to 5. Now, 0, 1, 2, 3, 4, and 5. Is this correct? I'm saying S2 will be from 0 to 5. Since S2 I have defined as 5 minus X1, it can ranges from 0 to 5. So if I allocate no teams, sorry, if I allocate all the 5 teams to X1, then it will be the remaining teams in at the next stage will be 0. If I did X2 equals to 4, that means I have given 4 teams to country 1, then I'm left with only 1 team at stage 2. Is this clear, guys?
Sir, why we are allocating all the teams to country 1 first?
I'm not allocating anything. I'm saying this is the number of teams available that I can allocate.
Correct.
Maximum number of teams that are available.
See what state says, number of medical teams available for allocation. So when I'm starting at country 1 allocation, I am saying that I have 5 teams available, right?
Okay.
Then I will make a decision Xn. Xn can be 0, 1, 2, 3, 4 or 5. Is this clear?
Yes.
Now, if I take a decision that Xn should be equals to 5, then I'm left with 0 team to assign to country 2. You agree? Because 5 minus 5 is 0. If I allocate 4 teams to country 1, when I say, let me not write X1 here, write it X1. X1 is number of teams allocated to country N. So decision I'm taking is let's assign 4 teams to country 1. Then I'm left with only 1 team for country 2 and 3. Does that make sense? We are not allocating anything. We are just exploring what are the possibilities I have. And when I take a decision, which is Xn, in this case X1, number of teams allocated to country 1, that will change my states in stage 2. Is it clear to all of you?
Yes, sir.
Okay. So if I want to put the numbers, what would this number be, guys? 0, 5 to 0?
120.
You just need to copy this row. 120, 105, 90, 70, 45 and 0. So what it means, 0 means I have not allocated any team to country 1. So I'm left with all the 5s to be allocated to country 2 and thereafter country 3. Clear? Any questions until this part? Now coming to n equals to 3. Can you tell me the number of states for each of the state? So what are the various possible values S3 can take? So don't need to think much. Think of it. I have not.
Again, 0 to
Yeah, very good. Again, 0 to 5. Think of it as there is a possibility that I have not allocated anything to country 1. I have not allocated anything to country 2. So again, it will be 0 to 5. Fair enough? Now, when you are trying to decide your S3, you have to be little careful because all the links won't work. So which links will work between n equals to 2 to n equals to 3? Can you just quickly have a glance over it and tell me? Can I go from 0 to 0?
Yes, sir.
Can I
Sir,
go
all
from?
links less than those values will work.
Yeah, that is what S2 minus X2 will says. So 0 to 0 is possible. Is 0 to 1 possible?
no, sir.
Why?
All no teams left.
See, S2 is 0. No matter whatever you put, it will be a negative number, which we will take it as 0. So that is not a possibility. And if you want to understand from physical interpretation, you have allocated all the 5 teams to country 1. So country 2 is there is no no teams available. Country 3, no teams available. Similarly, you can draw 1. You can go from 1 to 0 by allocating x2 equals to 1. You can go from 1 to 1 by allocating x2 equals to 0. Okay. So similarly, थोड़ा सा cluttered diagram होगा. In fact, बहुत ज़्यादा cluttered होगा. Let's try to use different pencil for each one. So 0, 1. 0 का link इससे 1 का सारा link इससे 2 का link चलो ब्लैक ही रहने दो. 3 के लिए हमको दूसरा कलर चाहिए. So 3 again can go to 0, 1, 2, 3. The rest you understand, right? Fine here. Again, you can put the your costs as. How do we put the cost here, guys? What would be the cost here? 0, 1 to 0. That means we have allocated 20 to that team. Okay, tell me the cost. Let me see if you are following. What
But
would
for
be
all
the
top pair, 120, 220, and 320, it will be 20, 45, 75.
So you have to use this country numbers. Only thing it will be repeated many times. So 120 will become 20. 121 becomes 0. Is this right? 121 means you have not allocated any teams. So again 45, 20, 0. So actually you will be going like this every time. 45, 20 and 0. Here when you will come, you will do 75, 45, 20 and 0. And so on, you will proceed. Good so far? Any questions?
Sir, how 1 to 0 is 20? It's not.
Okay,
In country 2, one team was left.
one team is left at, so if I'm making it 20, how many teams I have allocated to country 2? If it is in the next stage, it is becoming 0, then, and we had one country, one medical team left, how many teams I have allocated? Read this number of medical teams available for each allocation. So how many teams I had available if I'm in this state?
One team.
One. Now I have taken some decision that has made it 0 in the next stage. So what is that decision, Moingi?
That team is allocated to country 2.
What's that?
That one team is allocated to
Country 2. So if
Yes.
one team is allocated to country 2, what is the your life expectancy increase? 20?
Yes.
So
Yes.
that 20
Yes,
has
sir.
come. Similarly,
Yes, sir.
1 to 1, I understand this gets confusing because you have to keep in mind that on the R, you are making the assignment how many teams I'm allocating.
So the other option 1 to 1, that means this team is already allocated to country 2. So for country 3, no team is there. That's why we are putting
If it is 1 to 1, how many medical teams I have allocated to country 2?
For country 2, we have not allocated anything. That team
We
is
have not
allocated to
allocated
country.
anything. So X2 becomes 0.
Achha. Okay, sir.
So I have one team available for country 3 now.
One team allocated to country 3. Then it should be 50, sir. One team allocated to country 3 will give 50%.
I have not allocated for country 3 so far.
Okay.
See, this was transition from stage 1 to stage 2. So whenever I take a decision, it takes me to the start of the next stage, right? Similarly, whatever decision you have taken, it has taken you to the start of the next stage. Now we have to come up with what we will do, how we will make sure that the assignment of teams will be done for n equals to 3. So how do we, finally wrap up this diagram? Okay, just tell me at the end of all this allocation, how many teams I will be left with? After you have done all the allocation, how many teams you will be left with?
0.
That is your final
No team,
state,
sir.
right? Now you can link all these. So if I am going from 0 to 0, what is the life expectancy increase? Just need to copy this one. 0. If you allocated one team, so 50, then 70, then 80, then 100 and 130. Clear?
Yes, sir.
Yes, sir.
Okay. So we are good to go, or anything else needs to be done?
Sir, for stage 1, why you didn't write for all the
Gaurav, can you be a little louder, please?
sir, for stage 1, like n1 is equal to 1, why you didn't write for all states, like all the teams 0 1 2 5 3 4
What is
5?
my state definition, Gaurav?
Medical team available at for the location.
So I have 5 teams, so I'm just written 5.
Okay. So
Now,
here,
yeah, go ahead.
so here the medical team 0, 1, 2, 3, 4, 5. Here's a number of team like.
It is number of medical teams. Read it. Number of medical teams available for allocation. Or let me also put it as number of medical teams available for allocation or remaining. Does that make sense?
Yes, sir.
These numbers I have written here are actually number of medical teams available or remaining that you can allocate. Does that make sense?
Yes, sir.
So if I make a decision xn equals to 5, it will take me to the start of the next stage. And it will become 0. I have 0 teams available. If I make a decision x1 equals to 4, then it will take me to that there is only one team left. Make sense?
Yes, sir.
All of you? Okay. Let's take a quick break and then we'll discuss the recursive relationship and then we'll try to solve it.
Sir, one quick doubt, sir. So
Yes,
in each of the stage, the numbers which you have mentioned 0, 1, 2, 3, 4, 5 is the number of teams that are left to be allocated, correct?
I mean, when I say number of medical teams available for allocation, what do you?
Correct. So in n equal to 2, when I say that number of 1, it means you are left with one team to be allocated in stage 2.
Yes, these numbers are actually telling you how many teams you have that can be allocated. So when
Correct.
I say 2, so that means I can allocate maximum 2 teams.
Understood. So the same example at n equal to 2, you have one team to be allocated, which means that 4 teams have already been allocated in stage 1. And for allocating 4 teams in stage 1, the cost is 105, and that's why it's 105.
Yeah.
Okay.
So this is 105 because this is the profit or maximize this or the life expectancy, additional life year you will increase if you allocate 4 teams to country 1. Is this clear?
Got it. Yeah.
Okay, let me just quickly tell you what we have done here so that the recursive relation we can write. The numbers you are seeing here, number you are seeing here is what is at your hand. That is number of medical teams which you have in hand and you can allocate to country 1. You do not care about country 2 and 3 so far. All you know that I have 5 teams. I can allocate to 0 team, 1 team, 2 team, 3 team, 4 team, 5 team. So xn is the decision, how number of teams allocated to country n. So based on each country, how many teams you allocated, you have the life expectancy increase that you have written here. So I understand what is the issue. From 5 to 0, what it feels like that you have not allocated anything. But 0 is actually representing in stage 2 as you have allocated everything to country 1. Clear?
Correct.
Now, if I say 1 team is left, that means I have allocated 4 teams to country 1. If 2 teams are left, I have allocated 3 teams to country 1. And corresponding objective function values I have given. So if I have allocated all the 5, the increase additional life expectancy increased by 120 into 1000 years. If I allocated 4 teams, it will increase by 105. So on, we have represented this as a dynamic program. Is it clear to all of you? Please feel free to, if you have any doubt, any clarity you want to, clarification you want. Okay, let's break for a break. And it's 10:58 in my watch, so 11:08 we will meet. I hope you guys are back. Any questions before I proceed into the general structure of distribution of effort problem? So this type of problems are fall under a category called distribution of effort. So any problem which follows this kind of structure. So the effort is 5 teams, 4 teams, 3 teams, 2 teams, 1 team. We are trying to, if we try to put it as a general structure, then N is the current state, sorry, the stage N, your state is Sn. You will take a decision Xn. Your next state will be what? Sn minus Xn. So distribution of effort. You are distributing that effort from one stage to another stage. Now coming to the Fn, as I was saying that any dynamic programming will follow. Now we have to come up with the recursive relationship. So if I make a decision Xn, assuming that the numbers which I have given you a table is Pn Xn. So Pn Xn, that will take to a stage which is F star n plus 1 Sn minus Xn. And assuming we are working what do you call backwards. So I know all the future numbers. So I will put F star n plus 1 Sn minus X as here. So this is the immediate profit or cost. This is the future contribution. For example, suppose if I take this length, suppose this one. So what is the immediate contribution to the profit? If I take this length,
70.
what is the immediate contribution, guys?
70.
70. That takes me to this state. Now it's all future. I will only put, if you remember, the optimal one we used to put it here. So all the futures, I will put it on this here, and that will be added to F star n plus 1 Sn minus Xn. So my recursive relation is Fn Sn comma Xn, which is equal to Pn X1, that is the immediate contribution to the profit, plus future contribution, optimal future contribution, which we can also represent as F star n plus 1 Sn for that state. So it will be Sn minus Xn, Sn plus 1. So what we want is optimize this F star Sn equals to maximum of Xn equals to 0 to Sn. That is the possible maximum I have. Pn Xn plus F star n plus 1 Sn minus Xn for n equals to 1 and 2. What can I write about F3 star S3? I have only written for n equals to 1 and 2. What about n equals to 3? Because n equals to 3, all future is 0 here. So we'll only compare which one is giving me the highest. So max of over X3, 0 to S3, P3, X3. Because future contributions are all zeros here. So I can directly write that. Is that clear?
Yes, sir.
So let's start making our tables. Let me change the orientation so that I have more space. Copy this one. So I hope screen is visible.
Yes, sir.
I'm gonna just write the table for our easy reference. Not complete table. 1, 2, 3. और थोड़ा सा side कर देता हूँ. 1, 2, 3 is the country. Number of medical teams here. 0, 1, 2, 3, 4, 5. 0, 45, 70, 90, 105, 120, 0, 20, 45, 75, 10, 50, 0, 50, 70, 80, 100, 130. This is the table for the data given to us. Let's start with. So we are solving backwards. So we'll start with n equals to 3. So S3, F3 star, S3 and X3 star. So what are the possible values for S3, guys?
Zero.
0.
Only 0? N equals to 3 means I'm making allocation for country 3. Is that right?
Yes, sir.
This is my N equals to 3, na? So I have all these states possible. Now, what is F3 star S3 if I am in state 0? If you are allocating 0 teams, if you have 0 teams left, how much you can allocate?
0.
0, sir.
So your optimal decision is 0. What is the profit or the life expectancy, additional year of life expectancy increase?
0.
If I have 1 team, how much I can allocate?
1.
See, look from here.
1 and 0. And 1.
Disappeared. We cannot allocate 1 or 0 because finally how many teams we are left with, Moingi?
1 team, sir.
Look at this structure. Okay. From this state and n equals to 3, 0, you can go to 0. If 1 team is left, finally how many teams are left? 0. If 2 teams are left, 0,
0.
because you will allocate all of them to the country, na?
Yes, yes.
Okay. So corresponding, these things will also become 0, 1, 2, 3, 4, 5. Tell me the cost, or sorry, profit. F3 star
0,
S3.
60, 70, 80, 100, 130.
Just copy
50,
this one.
70, 80. No.
Yes, now you guys are following. 50, 70, 80, 100, 130. So that is your for last stage. Easy one. Always the last stage is easy one because you know the final one. Now coming to n equals to 2. This is interesting. N equals to 2. S2, X2. F2, S2 comma X2 is P2 X2 plus F3 star S2 minus X2. Here I will write my F2 star S2, the optimal among all of them, and the decision X2 star. So let's start. What are the possible values of S2?
0 to 5. 0.
0, 1, 2, 3, 4, 5. Let me draw this also. Not go haywire. Chalo. What are the values of x2 possible?
That 0 to 5.
Very good. Now, I'm in stage 2 and my state is 0. What are the achievable states for, what are the achievable values for x2?
Only 0.
0. 0. Now I'm in state 1. That means I have one team left. What are the possible values of x2 here?
0 and 1.
0
0
or,
and 1.
so I'm looking at country 2. See, if I, where it is, country 2, if I allocate 0 teams, what would be my F2, S2, X2 value? So let me draw here. 1,
0 plus
Zero.
0.
0, and 1. This is the possible values. This means x2 equals to 1. This means x2 equals to 0. If x2 equals to 1, what is the profit I am getting? I am allocating one team.
20 plus 0. Sir.
Yes. नहीं पहले 0 को देखते हैं. Suppose I am allocating 0 teams to this one. So what would be the cost? Sorry, profit. Immediately, how much if I'm allocating 0? P2 x2 will be 0.
Correct.
Plus all the future costs. So I will reach to state 1. If I reach to state 1 in state 3, the value is 50. So 0 plus 50 equals to 50. See if I have done it right or not.
Correct, sir.
All of you, please check if it makes sense or not. At this stage, I need to keep in mind that apart from the immediate contribution, I also need to look at the future contributions. So if I make a decision that I'm in S2 and my X2 is 0, then what would be my S3 equals to? S2 minus X2. S2 is 1, X2 is 0. So 1 minus 0, 1. I will be 1. All the future cost will be 0 plus 50, and that is why it is 50. Is it clear to all of you? Let me show that on bigger
Yes.
drive. So based on this, we already know all future cost I can put here as 0, 50, 70. I'm telling cost, but you know it is profit, 100 and 100. Now I'm in state 1. Okay. If I make a decision to allocate one team, it will be 20 plus 0, all the future cost. If I do not assign anything, then it is 0 plus 50, all the future cost. That is what I have written, 50 and 40. Is it clear, guys? What would be from 1 to 2? Possible?
No, sir.
So
Not possible.
all will be dash. What is the maximum? Because we are maximizing among 50 and 20, 50. So I will take 50. What is my optimal decision in this case? How much to allocate? What is x2 star?
0.
0. Is this clear, guys?
Yes, sir.
Yes, sir.
तो clear है तो बाकी table fill करो. Go ahead, complete this table. I give you 10 minutes, assuming that you have to solve during exam this question, this table in 10 minutes. Because generally dynamic program takes like 15 to 20 minutes to solve. This is the biggest table of that, so I'm giving half of it, 10 minutes to complete it.
Done, sir.
Great. So for two, tell me the numbers.
Sir, for two, state two, 0th position 70,
Just
70,
tell me in sequence 70, 70 and
45.
good. Next.
Then 80, 90, 95, 75.
Okay. So
Then
mostly you have got it right. So your approach is fine. 115, 125, 110, 130, 120, 125, 145, 160, 150. So these are the numbers you will get. From here, you have to, make the optimal decision. So both of them are fine. So I will say 70, 0, comma, slash 1. Okay. Similarly, 90. 95, 125 and 160. So let's write this number 95, 125 and 160. That will be 2, 3 and 4. Okay. Now final one, n equals to 1. That is S1, X1, F1, S1, comma, X1 equals to P1, X1, immediate contribution plus thereafter F2 star, S1 minus X1, F1 star, S1, and then X1 star. 5, 0, 1, 2, 3, 4, 5, 160, 170, 165, 60, 155 and 120. 70 is the highest one. So can someone quickly tell me how did I get 160, this number?
0 plus 160.
So that is the worst one. So 0 because I have allocated 0 teams, and 160 comes from here because 5 teams were available. If I make 0, S1 minus X1 will take me to state 5 in stage 2. So the best possible value for the S1 is 160. Is this clear? Similarly, if I have allocated 1, then S1 minus X1 will take me to 4. So 125 plus 45 will give me 175. Is this clear? So you don't need to really draw, because working with this diagram would be little difficult because it is very cluttered. You can find the numbers like this. Is this clear, guys?
Yes, sir.
So what is the optimal value? What is the maximum value? What are the allocations we need to do? So how many teams to country 1?
1.
So let's start tracing back. Country 1, 1. If X1 star is 1, what state you will be in stage 2?
4.
If you are stage 4, what is the X2 star?
3.
If X2 star is 3, what state you will be in stage 3?
1.
1 plus 3, 4 you have listed. You have only one team left, right? So X1 star is equal to 1. So 1 comma 3 comma 1. This is your X1 star, X2 star and X3 star. What is the optimal value for your function F star? What is F1 star? F star actually. It is always this one.
170.
Keep in mind. Keep this mind. This has
170.
adding up all the immediate and all the future costs. So 107. Understood? So now you realize that how it has solved the problem. Although when we were looking why I'm allocating all the 5 teams to the stage 1 and so on, that is not necessarily what you have done. You have not allocated anything. You started backwards and then you started working with it. Okay. Any questions?
Sir, stage 2, can you just explain how did you come to number 3, sir? X2, 3.
Okay, so let's go in the complete diagram. I don't know why it disappears. Take time. Just give me a second, let it come up. Yes. So now we have solved the problem completely, Bharat. So
Correct.
let's look at here. What is x1 star? 1.
Correct.
If x1 star is 1, that means you have allocated one team. In the next stage, you will have 4 teams left.
Correct.
Right? Now, associated with the 4 teams, you have an x2 star. x2 star is telling me allocate 3 teams. That is the best one.
Correct.
So if I allocate, who's that mark? Okay, let me continue with. आ गया. Let me use some interesting words. So from x1 star, you have come here. Then you have taken a decision to allocate 3 teams. How many teams you are left with for the next stage?
One team.
One team. So the path you need to follow is अरे वाह, ये तो बस मैजिक पे निकल गया. So path you are following is right.
Okay.
Make sense?
Okay, sir.
So from table, what you need to see simple. Okay, this is my x1 star.
Correct. 170.
I already know the definition of S2, which is 5 minus x2. So 5 minus 1, 4. I will be in this stage.
Correct.
If I'm in this stage, this is the optimal decision. X2 star equals to 3.
Correct.
If this is 3, I know the definition of S3, which is S2 minus x2. So S2 is my 4 minus 3, which is 1. So from here, I will come to this one. And optimal decision for this one is 1.
Okay.
Make sense?
Okay.
Chalo. So this class of problems are called, as I said, distribution of effort problem. So we have seen 2 kinds
So
of
the
problems.
idea is just to find the path, right, sir, not the cost.
When you are trying to find the path, you are actually deciding the path based on the cost only, na?
No. So that one F star equal to 170, how did it come? I mean, is it because on the first stage it's 170 is the highest?
No, you have not taken that cost. See, when we were solving it backwards, we have some F1 star S1 here.
Correct.
Then some F1 star X1 here. And then
Correct.
finally P1 plus this one is giving me 170. If we look into this table, let's look at it. We have got 170.
Correct.
Right? Is there any allocation that can achieve? If I allocate 5 teams to country 1 or 2 or 3, it will not be 170. Let's look at other combination. So only possible combination, if you look at it, how much? 110. If you are allocating 3 teams here, 75. One team for country 1, 45, and one team for country 3. That will add up to 170. Just check if it is true
Got
or
it.
not. Right?
Okay.
Only see, based on this one, we are making this decision.
Understood.
When I was in this stage, I have these many options, right? Okay. So we have seen 2 kinds of problems. So the idea of looking at different kind of problems so that when a new question comes, you try to see if it matches to any one of them. And then it becomes easiest to solve. So we have second shortest path, second distribution of effort. Now next problem is actually little, I need at least 1 hour, but I will start today so that you guys have pasted it somewhere. Come on, disappear. Oof. Ha. Read this question carefully. We'll start this question and we'll continue it on Thursday. So now we are going to see a scheduling problem. How to schedule a production planning problem. Are you guys able to see it or it is too small?
Sir, can you make the screen landscape? Yes, sir. Okay. So we can see it now.
Yeah. Great. Oh. Again disappear. Oh, you guys cannot see my screen, right?
It's not.
It automatically stopped sharing the screen. Yeah. Is the question clear, guys?
Sir, this can also be solved using linear programming.
Yes, of course. It is a production planning problem, right?
Yes, sir.
It can be solved using linear programming problem. So many of the problems actually we are looking at, definitely we are looking at small prototype example. When the problem size is very large, dynamic programming can give you a result much faster than linear programming or integer linear programming. Okay. So let's start with what are the stages here.
So stages are the seasons, sir, and states are actually continuous.
Yes. So actually, if you look at it, there will be indefinite stage because we are looking at, I don't know how long in the future. Does that make sense? When I talk about stages, it will be indefinite because I don't know how much in future we are looking into it. But at least for 1 year, the cycle should be like this only. For 1 year, the cycle should be something like this or something like this, whatever you want to put it as. You agree? Although this thing will repeat again and again and again year after year, but at least one cycle of 4 seasons, the requirement level will be like this. You agree or not?
Yes, sir.
Yes, sir.
So my stages can be the season. Always when you are planning a stages, now keep in mind for whom I am making these decisions. So I'm just making decision for spring, summer, autumn. The last question, we are making this decision for country 1, country 2, country 3. So if you ask the question, you will get the answers as your stages. So I will have n equals to 1 to 4. Now, interestingly, stage 1 should be spring or stage 1 should be summer. So I have defined, let me write it little neat. My stages are seasons n equals to 1 to 4. Now, if these are my stages, what decision I need to take for these seasons?
Number of employees.
Number of employees. So let me say Xn equals to number of employees. Okay. Now look at the problem carefully and tell me my season 1 should be summer or my season 1 should be spring. Keep in the mind Xn. What is the minimum requirement for season spring?
255.
And that is also the highest.
Yes.
So what should be the requirement or the number of employees per spring?
Sir, it should be start with summer.
You guys can hear me?
Yes, sir.
Yes, sir.
I don't know, I just brought my iPad near the laptop and laptop just got all blank. Anyway, so let me go back to, so tell me, what is the, the peak season requirement equals to 255. Do I need to keep the minimum or maximum for spring?
Sir, whatever we keep, we should have a previous value so that we know the difference to get the cost. So we can start from any value, but probably, like for example, if we start from autumn also, we should have one value of summer like before that.
यार उसीलिए तो बोल रहा हूँ ना, one value of summer तुमको पता रहेगा? You know the minimum, right?
Yes.
Now I'm saying, you being the manager of that company, okay, what is the peak season requirement you have?
For spring, 255.
Okay. So how much I should keep in the spring season?
So that is the means requirement. So we should have minimum that many number of, means we have to have that many number of employees.
Okay. Anyway, you guys think about it. I will discuss it on. I have uploaded it on Teams. So you may see some blank. It is on page number 10. Read this question carefully and think which one I should pick as my stage 1 and which one is stage 4 and why. Okay. Try it and we'll discuss it on Thursday, and that day I will wrap up the dynamic programming. I will get after that 1 hour to discuss few more things on Monday, and I will also announce your class test by date and everything by tomorrow on Teams. Thank you guys. See you on Thursday. Bye bye.
Thank you, sir.
Thanks, sir. Thanks, sir.
Thank you.